is the co-founder of Thoria and associate research scientist at Harvard University. He recently obtained his PhD in information science from the University of California, Los Angeles, with a dissertation on scientific collaboration networks. Prior to starting his PhD, he worked in the information technology department of CERN, the European Organization for Nuclear Research in Geneva, Switzerland. He holds an MSc in computer science and a BSc in astrophysics, both from the University College London, UK. He was born and raised in the winemaking town of Manduria in Puglia, southern Italy.
I like the fact that I always put that last line in my bio, and people always read it about where I come from. It's a great place, winemaking town. Thank you so much for the introduction. Thank you so much for having me. So as you can tell from my background, I'm a research scientist by training. I've been doing research for about 15 years. And while doing research, mostly in astrophysics and information science, I was writing research papers and mostly hating it. So I decided to go ahead and build a tool that allows not just myself, but researchers in general to write research papers in collaboration in a much more efficient and seamless way. And the platform is called Thoria, and that's what I'll talk about today. So I normally speak for about 10 minutes, and then I actually have a demonstration for another 10 minutes. I know that demos are not always like the best way to impress people because they always fail, something always breaks. But you know, that's my style, so I'll embarrass myself with that. When I mostly speak to scientists. I don't normally go to publisher conferences, well, from time to time. But when I speak to scientists, I always like to start my presentations, and I will do the same today. You know, really describing in general, you know, like a top sort of bird's eye view of what scientists do today when it comes to publishing and writing. So I think that scientists, we all agree, they produce cutting-edge research. By definition, science is about creating something novel and original, so we can say 21st century research. But if you look at the tools that most researchers, scholars, scientists use to actually write the research, these are tools that were actually designed in the last century, so 1980s mostly. Microsoft Word, which is by large the tool that most people use to write research, was intended to be used by one person who's working offline. LaTeX, which probably most of you don't know about, or maybe you know, it's used by 5 or 6% of the scholarly population, mostly the physicists, astronomers, you know, those guys. It's a typesetting format, really cool, powerful. I also hate it, but it's a it was built to be used by one person working offline. Then if you look at the actual format of scholarly papers, well, actually, the format hasn't really changed much, you know, in the past, well, 400 years. So, you know, we still publish papers that essentially look exactly like that. So I enjoyed very much the keynote presentation, you know, by Wiegert. I'm sorry if I'm saying your name wrong, but what he said about, you know, essentially it's paper behind glass or dumb content on a smart device. Well, that's what I'm talking about. We essentially replicated exactly the way that articles looked on paper and just brought that to the web. So I just want to make that point even more, and I want to, as an example, show you one of the first articles ever published by Galileo Galilei, actually a guy who's also from Italy like me, but he was writing research 400 years ago, and this is the style that he decided to use for research paper, and that's pretty much the style that we still use today. So for the past 3-4 years, I've been complaining about how papers today look exactly like they looked, you know, 400 years ago. But then, you know, my postdoc advisor at Harvard, Alyssa Goodman, she told me, like, have you actually read this paper? I was like, well, no. And she's like, well, look at it. And then we read it together, and if you look at the paper, it's actually, well, this is the English version, of course. Galileo was writing in Italian. So if you actually look at the paper, it's got a very narrative account of what Galileo was doing on a starry night, you know, 400 years ago. It's actually very beautiful, romantic, and it's describing as it goes along, you know, in this very subjective way, what the instruments that he's using, what he's actually seeing, and then all the data that he's collecting. Now, he's not just presenting data saying like, oh, I collected this and here's a table of my data. is actually showing in the article all the data he collected. He was like looking through the telescopes, making the drawings, and he published the drawings. So my point here is that what Galileo was publishing was essentially an annotated notebook. He published the science he was making, that's what he published. Now today, things have changed because the data are much larger, and mostly we end up building data repositories, and we publish a paper that looks like that, but it's just a table of the final, the results that we analyze and process. All that analysis and processing is entirely lost from the final result that they end up sharing, and that's bad for science. It's bad for transparency, for reproducibility, so it sucks. So my question is, 400 years from now, or if Galileo was around today, a hipster kind of Galileo with sunglasses, what would he do? If we had to rethink scientific publication today, how would we do it? But my point is that we would probably choose some sort of paradigm that does not involve necessarily distributing PDFs, the dumb content on smart devices, but probably, delivering smart content on smart devices. So that's essentially the bottom line motivation for building Autoria, which is a powerful tool for collaboration, first of all, and also for disseminating research products that are not just a finished PDF. So I don't know how much longer I have, 10 minutes? Is that about right? Yeah? Okay. So normally I go along and show some memes about LaTeX, but I'm just going to skip the entire thing. Probably I'll just show this one. One problem we're trying to solve is clearly collaboration. A lot of researchers end up spending months, like 6 months, to write papers instead of weeks. So if for you guys, most publishers, you're trying to reduce publishing times, the reviewing times, I'm working with authors to try and reduce the amount of time that it takes them to actually get a paper out. So this problem of exchanging papers by email, that's the first problem we're trying to solve. It's also the problem of version control. A lot of people don't realize that if they're using email, well, you have some sort of idea of what's happening and who's writing what and who's contributing to what. But a lot of people now use Dropbox, which is a terrible, it's a great system, I love it, but it's a terrible tool for version control. If you have two people working on a file at the same time, you end up corrupting the file, and essentially you lose work. So, we love Git. I don't know if you're familiar with Git, but, we love the idea of a proper version control done the right way. The last slide I want to show is the idea that we're also interested in attribution and giving credit to the, whoever did the work. So you don't want to send your manuscript to the second author, and it's happened to me. I ended up publishing as a first author stuff that was changed by my second and third authors without me even realizing. Because if you just pass it around by email, at some point you lose track. Even if you read the paper one more time at the end, you essentially don't know what really happened. So proper tracking so that you know what's happening at any time. So you can see this, so it works okay. It's probably not the best view, but you get an idea. So I just sent it into Autoria, which, by the way, if you go to the home page, it looks like this. Hopefully it works. Yes. So write research together. We're about writing research together. If I log in as myself, you get to a page that looks like this one. It looks like a little bit like a blend of a social academic profile with my photo, my affiliations, some people that I collaborate with, including Albert Einstein, as you can see. And then there's a number of papers that I'm working on. I'm gonna, just for the purpose of demonstration, I'm gonna call this Emerging Scholarly. Just gonna create a new article. I'm gonna call it, if I can write something, that, and I can make it public or private. I can also choose some advanced settings, some cool templates if you're writing a grant proposal or I don't know, F1000 research article. These are all publishers or conferences that are in touch with us to be added there. But in a way, you can just start with a blank article, and that's what I'm going to do. And once you get started, this is what you get. Just make it a little smaller. Wow, this is looking really weird on this thing. Anyway, yeah, you can sort of see this. I can double click anywhere, and I can input some text. Okay, so hello, I am changing this. Making mistakes as I go along, but as you can see, the text is changing. And just because I've been talking, criticizing LaTeX, I'm gonna add some LaTeX code from here. Sorry, I have like some saved LaTeX code. See, it looks ugly, and if I go to the main page here, I can just copy and paste LaTeX, click save, and now, as you can see, the LaTeX is rendering. The cool thing here is that I'm not actually rendering, I'm not compiling any PDF, I'm just rendering LaTeX or Markdown, anything, to the web, to HTML, and it works. So that's fantastic. Another thing you can do, which a lot of authors especially find very useful, is I can create tables, for example, on the fly. I can just say, give me a 3x4 table, boom, put the numbers in, and it's done. Another cool one also for authors is the citation. This is probably the most important and powerful feature we have. If I want to search, for example, for papers by Amy Brand, I just type in Amy Brand, I can search PubMed or Crossref, search Crossref, for example, and we have some papers by Amy Brand. I'm just gonna cite this one, for example, published in the Encyclopedia of Library and Information Science, and I hit save, and the paper is added here and in the references. So if there's an author, and of course we also integrate with Zotero, Mendeley, and EndNote, so we make it really easy for authors to just cite stuff while they're writing. We also have commenting, which I hope it will work here, so you can highlight anything you want, click comment, and here it's hidden for some reason under thing, but you can type blah, 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 comment, and the comment goes in. Sorry about this, this is something, oh yeah, here it is. Well, sorry about that. And then I guess the last thing I'm going to show, because I'm taking forever here, well actually two things I'm going to show. First one is you can drag and drop any figure you like into the paper, and it will just take a second, but finally the image gets uploaded. And in addition to adding an image, you can also attach data. Any type of data set. We also love Ipython Notebooks. I don't know if you are familiar with those, but if you have an Ipython notebook somewhere, you can just add it and open it, and that will add a little launch Ipython thing, which allows you to essentially upload not just the data set that is behind an image, but also allow the authors, here it is, to interact with the data, the code behind a scientific plot. So I think this is like what in the previous talk, the keynote speaker was talking about. I was talking about make data actionable, because you actually allow the readers to look at the data behind an image. And in this case, it was an image of my hometown, but you can imagine it could be it's actually not my hometown, it's outside. But you can have an actual image of something in there with scientific data and attach the data to the thing. Now, the last thing I want to show, and I promise it's the last thing, is the export functionality, because it actually applies to a lot of publishers. If you click export, you can format your paper in any format you like. We now support quite a few formats. I was talking in the roundtable discussion to someone from PNAS, so I'm just going to choose PNAS for now, and it's probably going to look fantastic, but if you click PNAS, you can just export your content. So we're like format agnostic. You just format your paper at the end, and you download your document, and if it all goes well, just 1 second, it should be formatted for PNAS. And there it is. I mean, it does look a little, I don't know if PNAS will publish this,
yeah.
But you know what? If they don't, you just go back to export, and in one click, you can, I don't know, submit to Elsevier. Boom. So the idea is to really make it easy for authors to, well, not submit to multiple journals, but a lot of authors we talk to spend days just reformatting papers for submission, and here's an easy way to just, have your papers ready in seconds. And I'm going to stop there. Thank you.